Time here then to take a look at IK, or inverse kinematics, and how we use it all. On the surface it all seems pretty simple, and in fact it is actually pretty simple to use and get along with once you understand it fully. But to do that there are quite a few bits of detail that need to be picked over. So what we're going to do is start with the most basics and gradually work our way through all of the pertinent little bits and pieces that you will need to know to get the most reliable solves out of your IK. So we start here with a simple little arrangement, the most simple arrangement available for IK. Notice of course I'm using bones. This could be anything, could be objects, cameras, lights, doesn't matter. Like everything else in Lightwave, IK is just a form of motion control. It can operate on any item type. How it all works then, you will have a root to your IK. In this case we've just got the bones belonging to a null object. You will then have the items themselves, which will be controlled by IK, which in this case is going to be these two guys, so a 2-bone IK solution we're looking at here. We then have this third bone stuck on the end, which you always need to have there. Whatever kind of items you're using, you always need to have an end item in the chain. And we have this little null helpfully titled G, which is our goal item. So the basics of setup are very simple. You take the items that you want to have IK control on, in this case these two bones, and we're going to operate them for this example in their heading axis on IK, and we simply set their heading controller here to be inverse kinematics. We come to the last bone in the chain here, the last item in the chain, and that is what directs the solver toward our goal. So on the IK and modifiers tab we grab the goal object and we pick the goal G. And what we'll notice, I'll switch to the top view here, is that our IK chain is doing its stuff just like that. Pretty straightforward and easy. Now, first thing I want to draw your attention to is the shaping of the chain. You'll notice here that my chain is perfectly straight, and if I pull the goal item back just along the Z here, so perfectly in line with the chain, nothing at all happens. It only jumps to when I nudge it off to one side or the other, and you can see that the bend in the IK chain goes in the direction appropriate to the side which I've pushed the goal. This introduces us to the first idea, which is pre-bend. When the chain is completely straight like this, the solver has no way to know which direction you're intending to bend it in, which is why it bends counter to the side of the direction which the goal is pushed to and creates no bend whatsoever when the goal moves perfectly in line with the chain. The first thing that we want to do is create some pre-bend in our setup. That's simply done just by creating a base FK rotation on one or more of the IK items here, and what we get as a result of that is the IK chain now has this as its preferred angle, and so when moving the goal like this in line with the chain, it will bend in that given direction. And the same, of course, you can see as we go side to side. If we go too far, we start to get the flip. We'll see how to fix that in a second, but that's the basic idea behind pre-bend. So, fixing the little jump over there. Well, we only pre-bent this one item. We get better reliability out of the pre-bend behavior if we also bend the other item. So this one bends out, this one bends in. At this point you'll notice we start to get a more stable chain that doesn't flip as much. Of course, if we come too far we still get a flip there, and you see as the goal starts to come close to the root, it dodges back and forth an awful lot. The reason for this is because currently this second item here is allowed to pivot both ways. It can go in either direction. The IK solver has no way of knowing that it shouldn't go this way, perhaps. Obviously, were this a knee or an elbow, we'd be wanting it to bend in this one direction, but not back in the other one. And we fix that by using the limits. So in this case, I'm going to say that its minimum rotation is 0, and I'll leave its max rotation there at 180. And what we see as a result of that is that the IK chain no longer does that flip. And if we zoom out with this guy here, we can see that we can actually come right around the clock, and the bend direction and everything else follows as we'd expect it to. So having pre-bend and limits you can pretty much take as a given for any IK chain in order to get it bending in the direction you desire. Now pre-bend is an interesting thing. If I set everything back to just be straight and in line again, what we will see is we can actually create pre-bend without doing any bending. because what the IK is looking at is the position of the pivot points relative to one another. Hence, if I push this bone to the side like this, then the IK solver will interpret that as prebend, no different. And we see here again that it all works just the same way. May seem a little strange, but if I take the bones here and I just temporarily convert them over to joints, then we can see, of course, how this translation of the position is basically equivalent to prebend of a fashion. Of course, we notice that the axes aren't aligned with the joint deformer portions, but there is this clear bend between the pivot points, and that is what the IK solver sees. Hence, we're able to make it work in this sort of a fashion no differently. And that can be useful in certain setups when we need to apply prebend to a chain, but we want to keep the axis aligned in a certain way, or we want to keep the base axis block in line with one another. So, positional offsetting to create prebend. Handy little trick. I shall now, however, just revert back to the previous method that we had. So, on to the next point about IK. What we can notice so far, of course, is that I'm doing this all flat on a plane. Our IK chain here is moving around completely on the flat. If I move the goal down, then nothing happens. Of course, this is because IK is only operating on the one channel here, heading on this first bone. What might seem like the most obvious solution is to take this first bone and give it IK on other channels, for instance pitch. And as we can see, that will get our IK working up and down and around and around. However, this kind of system for IK is pretty unstable. We can see right there already, notice how the goal has drifted away from where it ought to be. It is no longer at the point of this bone. Getting a good solution for 3D IK, as this would be called, is very tricky, and we'll notice that in an awful lot of poses it tends to fail quite miserably. The only way to fix it being to swing things around, which also doesn't give us very predictable behaviour, as we can see there, with the alignment of the goal and the actual goal point in the chain only meeting up at certain axes there. This, of course, is related to the way that rotation order works in Lightwave. Would this have been any different had I put the IK here for this second bone coming around on pitch instead? No, it wouldn't. I would have exactly the same problem. I'd just get it in a different pose. This reveals the second important fact about using IK in Lightwave, and indeed most other packages, is that you need to keep your IK planar. It must always be flat. That is to say, when we look at it from view 3, the entire thing exists on a single line. The joints, the goal, everything, all on this single line. Or, of course, flat as viewed from above, like this. This, of course, presents a clear problem when we're trying to build arms and legs and such like that do not operate in a single plane. They roll around from the base, going up and down and side to side. The way to deal with this is to basically use an IK plane at the head of the system. Simply, all we do is add an extra item, or bone in this case. I'm going to give it a different colour just to make it clear. And I'm just going to rename it IK plane, again for clarity there. We take this item and we make it the parent of the entire system. So we would parent our first IK bone to it there. We then take this first item in the chain and we target it at the goal item. Note for a moment that I do have IK disabled here, and of course what we're seeing is that that bone performs a target in, of course, the side to side and the up and down. If I now re-enable IK, we can see that what we're getting is this fully functional 3-way or 3D IK chain. Of course, we don't really have a 3D IK chain, we only have a 2D IK chain. The IK is still planar. This is most easily seen if I put a little grid shape on that first item there. So we can see, of course, that the IK chain itself is always moving on this plane, which is commonly referred to as the IK plane. The IK plane is what rotates around to point directly at the goal, and then the IK itself can behave and work in a 2D fashion within that plane. Furthermore, to create additional pointing of the knee or elbow, we can simply rotate that plane, taking the entire IK system with it. And this gives us a complete rotational freedom for our IK setups, just like that. Notice the important point here: in order to work properly, then our first IK item and the IK plane item both need to share the same pivot point. They must be right on top of one another, or at least they must be in the same plane. You'll notice, of course, I can move this in the XZ there, but of course moving it off in the Y pushes our IK away from its goal. Otherwise, keeping our IK on this plane is very simple and gives us a stable and reliable IK solution. Though, of course, if I have pushed my first IK item off like this, then when we come to get roll for the chain, that won't happen from the point of the first IK item, which in the case of a shoulder or a hip is going to look a bit weird. Therefore, always best to keep them right back at the same position, resulting in a lovely, predictable, useful IK chain. Before moving on, I want us to take a closer look at this idea of planarity, because there are a couple of interesting little side notes that emerge from it. First off, it's very easy to see what happens if you violate planarity in the actual initial setup and orientation of the items in your chain. For instance, if I've got this turned off somewhere on pitch, we can see, of course, that we just get drifting away from the goal there. And similarly, if I have the same done here. Of course, since our plane is here and our rotation axes are on that plane, that's the important point I should point out, that the rotation axes of the items in the IK chain are aligned with the plane. We can see here the heading is flat on the plane. That is all that matters. So I can take my items and once again push them out in this sort of a fashion to create something that appears to be non-planar, but because I have used translation, the actual rotation axes themselves are still planar, and so the IK chain still works. Looks a bit weird here, but of course viewed from the top, viewed in the plane, it appears absolutely no different. Again, seems strange with Z-axis bones, but a little conversion over two joints gives us a visual representation that makes a bit more sense. And we see that having a non-planar IK chain is possible, but only if we use positioning to offset items from the plane. Their rotation axes must still be on the same plane. This can be an important trick in certain situations. For instance, let us consider a character like this, a simple cartoon character, but creating this heart teardrop shape for the lower legs. What we would want in such a situation is for the hip to be somewhere around here, then the knee to be cut in here, running straight down to the ankle. This violates the planarity of the chain. This would be no good for IK. We would get a separation of the goal from its position. However, by setting our controls in their orientations thusly, we could get this kinked sort of a chain that maintained planarity for the IK. Another point worthy of note is an alternate way in which this can be done. On this second item here, I can move down within the plane or orthogonally to the plane, and I can still rotate it up on its pitch thusly until we get the correct meeting point for the goal. And the system set up this way will also still work as expected. In this case it works because I'm using heading for the IK, of course heading being the primary rotation axis for any item. Had I set this chain up the other way so that it was a pitch-based IK system, then I would be unable to use that particular method. As we'll note, if I offset orthogonally here, I have no axis to rotate back on because of course at some point this second joint achieves gimbal lock, and so trying to fix it in such a manner would never work. It will fix into place on some poses and then just drift when you get into others, and you'll get problems like this occurring. Once again, this is an excellent example of why you should always favour heading above pitch when setting up motion control for items on rotation, most especially for items that only need to bend in one single direction. Getting into the habit of using heading rather than pitch will give you more flexibility. And as a small side note to this, do notice that it's perfectly allowable and possible to cross over axes within a chain. So for instance here I've got the pitch working on IK on this first item in the chain here, but then the next item is oriented at 90 degrees and it's using heading on IK. The IK for each subsequent item in the chain does not need to be on the same channel as the other items in the chain. You can have this kind of crossover for things and it will still work in exactly the same way. Therefore, if you do get into a situation where it's advantageous to have perhaps the first item rotated one particular way, but you want to get the heading option on the second item, you can counter-rotate or reorient it relative to its parent thusly without problem. Just one final and very important little note then on the basics of IK here is what happens when you have multiple chains in a rig. Clearly in these little demonstrations so far we've been looking at one IK chain in isolation, but many setups will have more. So what we can see is I've added a second chain coming off the same root null object here. And what we notice is that when I manipulate the goal of one chain, whilst it works, we see the twitch in the second chain here. See it going there, twitching around, and of course similarly when I move this goal here, the other one gets a tiny little twitch going on in it. The reason for this is that the IK chains are not terminated. We notice here on the IK and modifiers tab this checkbox for unaffected by IK of descendants. What this does is terminate an IK chain at its top. At the minute, because both of these chains exist within the same rig under this main null object, the IK calculations flow between them from one to the other, and that can give you this twitchy follow-through behavior that you get in this manner. By taking this null, which in this setup is the root item at the top of each IK chain there, and setting it to be unaffected by the IK of descendants, that will basically kill off this behavior. And so we see now that each IK chain is completely independent and doesn't have any effect on the other one. So that's a very important little side note there. Always terminate your IK chains at their tops. So then, let's start having a look at some other setups. We're going to look at the 3-bone IK setup here. The process is pretty much the same. I'm going to grab my items here and I'm going to set all of them to operate on IK, again with the last item in the chain reaching for the goal object there. And let's see what happens. Well, we can see IK chain is sort of working. It's a little twitchy there and sort of flopping around. Again, we can attribute some of this to limits that are not yet imposed, so we'll put those on nice and swiftly. You can say that this one only wants to go in this direction, so we'll lock it thus. The next one we'll say, of course, going in that direction, and lock it thus. We don't need to usually worry about the locking of the top item. What we now see is that our chain isn't turning itself over as it did before. The limits are holding, but you'll see that the amount of press out that we're getting in the chain is very difficult to manage. It's very floppy. It's not collapsing in some of the ways that we might want it to. We might want something of a concertina or zigzag style behavior coming out. The chain clearly isn't breaking, it's behaving itself, but it's not using a particularly predictable way of going about it. It's at this point that we want to turn our attention to one of the settings in the motion options panel, which is the stiffness parameter that we see here. The stiffness setting on items is pretty much there, strictly for IK, and what it does is change the preference for how and when a bone will bend, or an item will bend. So for instance, I might take this one down, which wasn't bending an awful lot until I came really tight into the root with the goal, and set that to say 0.5, and then maybe I'll take the stiffness for this guy up to 2, and what we'll see we get is a different behavior out of the chain. This first joint over here is bending more readily, and this second joint is doing less so. And whilst this gives us a different behaviour, it's still kind of hard to predict exactly where it is and isn't going to bend to in a given pose. And that, of course, can be problematic for animation. In case you haven't noted, by the way, this would be the sort of setup that you might wish to use on some animal limbs, like quadrupeds or insects that have 3 bones along their leg and so on. Of course, we saw in the foundations how we can just mimic that with the regular old 2-bone solution, and we can, but clearly Lightwave's IK can handle multiple numbers of bones, and that's one of the other facts that we're introducing now, the number of bones that Lightwave's IK solver can handle. It's not restricted to just 2. It can do 2 or 3 or 4 or any number you like. In fact, it can even do 1, and we'll see examples of that at some other point. But for now, let's just worry about this chain here. So, what else could we do with this? Well, there's one very easy solution to using a 3-bone system, and that is to take, let's say, this first bone. It could just as easily be the last one here, but let's say the first. You would not take the middle one, and we're just going to turn it off IK and back to keyframes. That then leaves us with a 2-bone system, which is of course entirely predictable, and the third bone in the chain can then be operated manually, and this gives us our overall control and predictable amount of press in the chain. This again is more or less what we saw in the foundations video, except we'd used this last bone on FK and made it part of our reverse foot rig. Let's have a look at another way that we can do such things. I'm just going to turn this guy back to base there and put him back on IK. What I'm going to do is I'm going to add another bone to the chain here. Notice it is a child of this first one, although realistically it could appear at any point in the chain. I'm just going to give it a little colour here to make it stand out. And I'm going to take this second bone and make it a child of that one. Now this bone, you'll notice, is of course all operating on keyframes, no IK there. But the 1, 2, 3 main bones of our chain are all on IK. What we now get is a 3-bone IK system like this, but we can control the press by manipulating this bone here. Essentially what this does is it pre-rotates this fella here, thereby causing an alternate solution to be generated for the IK chain. And we can thus get this to behave as we want it. What you will notice, of course, using this kind of system, whether we've used this extra bone or whether we had one of these 3 bones set to FK with a 2-chain IK solution in the whole thing, is we've always got 2 controllers. You have your goal and you have your controller that operates the amount of press or tension in the chain. This will always be true for chains of more than 2 bones. You will always have to add extra controllers, irrespective of how you choose to do it. And of course, irrespective of where in the chain you choose to place them. Notice, of course, that we could make this press bone, this offset bone, whatever you like to call it, be the top item of the hierarchy, like this. Again, we would get a similar sort of setup where we had a 3-bone chain and this bone creating a pre-rotation that caused the chain to press out one way or the other. The end result is basically the same, although you can see here that smaller adjustments to this bone are having greater adjustments to the chain below it than we had when it was at this second joint position. We could of course start trying to do clever little things like perhaps add a null, which I'm just going to call T. I'll make this a child of the goal object, put it out here somewhere, let's say. I could then take that bone and target it to T. This of course would have the effect of making the operation from the goal completely predictable. And of course, because that null is a child of the goal, then further rotations into the goal would cause it to turn around. Or of course we could grab this item and translate it directly, working in this fashion. We could have done the same with the initial setup where this bone was on FK and only these 2 were on IK. We could have used this targeted to some other null and have used that in a similar fashion. As you can see, lots of options. We could have worked this any number of different ways. And of course, there is no technically correct way to do it. All of these ways are valid. What matters is the kind of control and predictability that you get out of the system afterwards. And so going back again to what was said in the Rig Anatomies video in the Foundation series, this is one reason why it can be incredibly useful to use a uniform style system in the way that I had used the reverse foot rig in both bipeds and quadrupeds and so on, so as you had this same kind of system for animation later on. It helps to give you something that is predictable, irrespective of the character or character morphology that you are rigging and animating. With all of that seen, why don't we go completely wild and start adding even more bones and see what we get. Here we have 4 bones set up to use IK. You can see that I've set their rotation limits, and what I'm looking for is this concertina or zigzag style behavior. But what we see that we get is, again, we get this sort of thing that's not exactly what I wanted to achieve. Now, we can see some interesting points, like this joint here doesn't seem to be doing a lot of bending, so we can fiddle around with this, with the stiffness parameter, to try and get it to do more of what we want. But again, we see that it's not really performing that controllably. It's behaving, it's not breaking, but again, predictability and controllability is kind of a bit nuts. This is one of the other essential truths of working with Lightwave in IK, is that whilst it is possible to use any number of bones, the more bones you add to a chain, the more unpredictable it will become. As such, trying to set up these concertina style chains of IK just doesn't really work. As long as you have observed everything concerning orientation and planarity and so on, the chain won't break, it will reach for the goal, but getting the expected behavior is very difficult. Now, we could do what we did in the last example and start adding extra FK bones or setting some of these bones to FK. That's perfectly reasonable. But instead, we're going to take a look at another little fact of Lightwave's IK, and that's the ability to use multiple goals. So I'm just going to add myself a little G2 null here, which will be a secondary goal null for the chain. Plonk that over there. And in this case, I'm going to take this bone and give it this secondary goal item there of G2. And what we sort of have now is this doubled IK chain that works in this fashion. We can see that this is a lot more predictable now in getting the kinds of shapes and motions that we're after. We still have the odd error occurring, which is again due to the fact that we've just got so much going on in this one chain that Lightwave has a difficult time in keeping it all snapped properly together. But we will see ways of dealing with that. However, what we can see is that we can start to get these chains to behave themselves in the manner that we're wanting. And it does seem like there's some certain refinements here that we can probably do to get things working a little better. And certainly there are. Before we move on to all of these little details though, let's just take a look at something that's totally nuts. A 9-bone chain here, so really long chain. And what I'm going to do in this instance is I'm actually going to set both heading and pitch to be IK for this chain, and with no kind of locks or limits. And once we give our chain our goal, we can see that we get this nice behavior going on there. This means that we can use Lightwave's IK for setting up systems of this fashion, where we want certain whips or tails or tentacles or whatnot. You'll see that in a case such as this, in spite of the pre-bend, when I come across the center point, the center line of the IK there, I am still getting this flip from side to side. At the moment, that's because I'm operating flat on the plane, but because I have set these bones to be IK controlled on both heading and pitch, I can move my goal around in all 3 dimensions there and have the chain operate itself in a reasonably well behaved and proper fashion. and that's pretty cool. We may wonder why it is that I've gone for heading and pitch on this IK chain, when of course before we saw that that was such a bad idea. The reason on a long chain like this, or of course even longer, is the fact that each bone is only actually bending a little bit. The angle formed between each bone and the subsequent bone isn't that great like it was on a 2-bone IK chain. Therefore nothing is rotating to the point of getting into gimbal lock, and so I don't get that horrific drift where the end of the chain comes away from the goal. That makes this one of those unique situations where you can use multiple axis IK and have it work more or less predictably. What you can also do with a chain like this, and what can be exceedingly handy for getting the thing to behave or move just as you want it to, is to go back to the idea of adding FK offset parts. So once again I'm going to create this little bone at the head of the chain there, which of course is set to work on keyframes, and what we then see is that when I'm moving the chain, this case on the plane, so as it's giving the flippy behaviour, is I can use this guy to direct the chain in that fashion, and that of course pre-bends the chain into a given direction, preventing the flippiness. The flippiness will of course only occur when I cross the line, which is now of course dictated by this bone here. Bring that into center view there just to make it a little more obvious for you all. And I can get away with managing it in this fashion. I can also go further and put additional ones elsewhere in the chain. In this case you see I've put another FK controlled bone in the mid chain here, and by operating this I can get alternative behavior into the chain, letting me do S-bend style stuff, though as you can see it is much less predictable in the way that it goes, and we tend to get harsher breaks and other misbehaviors of that fashion. Of course if you add too much of this, if you put too many of these guys in, then you wind up with a state where you may as well of course have effectively just used an FK chain for the whole thing. So that completes our initial overview of using the IK tools in Lightwave. In the next video we'll move on and we'll look at some of the greater details of the tools that are actually available. Doubtless some of the eagle-eyed amongst you will have spotted things like the different goal objective behaviours, the base on keyframe, the chain, goal strength, IKFK, soft IK, match goal orientation, and all of these settings. These are the things that we'll come to next.